Here, our topic is applications of mathematics in music. We have many applications of mathematics in our daily life. One of them is music. We'll be wondering how music is related to mathematics. The relationship between math and music extends to many elements of both, and studying one can lead to success in another. If nothing else, the connection is an interesting one to explore. This discovery, along with many other accurate and inaccurate propositions, made Pythagoras one of the father of music theory. Although it might not be apparent on surface, a strong and relieving link exists between the discipline of mathematics and art of music. The relation between Pythagoras and music. The Greek philosopher Pythagoras was one of the first historical figures to emphasize the relationship between mathematics and music. Pythagoras made one contributions to mathematics as well, but his theories of music are what interesting us here. Perhaps his most important contribution to our understanding of music were his discoveries in the realm of harmonies. Pythagoras realized that intervals of music could be expressed as numeric ratios. Here we can see how Pythagoras made his discoveries. Pythagoras, who made very important discoveries for mathematics and music. This is how he shown above octaves he discovered while playing with a third string. When we play two notes of the same time, we are composing a sound that hits x time per second with another that hits y time per second, resulting in xy fraction. If the smallest from the fraction results in small numbers, it means that the rhythmic pattern can be more easily interpreted. In other words, each note has associated rhythm, and the human brain interprets these rhythms in a range of pitch, high or low. The overlap of two notes in the fundamental physical system is rhythmic overlap. If the resulting rhythm continues of simple and interpretable pattern, the sound interpretation is more pleasant. Here we can see how logarithmic graph and piano body relate. We can see the graph and body of piano seems to be same. Here we can see how the equation can be represented as: when a string vibrates, what we hear is not a single pure sound but a superimposition of several sounds whose frequency are all multiples of fundamental frequency. The fundamental frequency is the main one which contributes the most, and other multiple frequencies are called harmonics. The amount of harmonic adds richness to the sound, give it body. Example: tuning fork. Here in this image we can see mathematics relating to musical scale. Math and music are two entirely different fields of study, but there is a strong correlation between them. At some point they tend to overlap, and it is common for people good at math to be good at music. It may seem illogical to compare the two, but there are more similarities between math and music than you would imagine, and you can use numbers and mathematical principles to teach or learn music. Coming to conclusion, although we have only scratched the surface of an incredibly vast and intricate subject, you have hopefully gained the start of a new perspective on mathematics, music, and the relationship that exists between them. Mathematics can sometimes seem abstract and remote from everyday life, but as you can see from our discussion about its relationship to music. Mathematics is a subject that actually plays an integral in our daily life experience. Thank you.